Hey guys, this is Miss Hendee. It is Tuesday, September 29th, and we are going to go ahead and go over our mountain math for today. So if you will please go ahead and put away your pencil, get out your red pen. You should have all of this filled in. You know how to do all of these problems for today. But if there's something that you didn't quite get, or if there's something that was incorrect, if you will just go ahead and correct it with your red pen, then you will be able to get credit for today. So let's look at number 6, the problem that you have already written in. Even if you didn't quite know how to solve it, you're always writing in the problems from the board. In your box, you've written n minus 79 equals 146. So first, we need to solve the equation. So we write down the equation, n minus 79 equals 146. Now I want to undo subtraction, so what am I going to do? That's right, I'm going to add 79 to both sides. So once I've done that, I have n on the left, and I have 146 plus 79, which gives me 225. Excuse me. Now we always want to check our equations and plug back in. Remember, one of our algebra rules is plug it in, plug it in. So we're going to rewrite the equation, plug in what we think n equals, which is 225, and see if it fits. And you'll see that 225 minus 79 does give us 146, so we can put a check mark. It is correct. C just asked us to write it in words, so n minus 79 equals 146. So please make sure that you have all of that work and that you are ready to go. All right, number 7, you've written in your box 3 times 3 times 3 times 3. That's a lot of 3s. So we're going to first evaluate. All that means when we see the word evaluate is to figure out what it equals. Evaluate means to solve, to simplify and to get the answer. So 3 times 3 is 9, times 3 is 27, times 3 is 81. And actually, I went a little too far on mine, so I'd like for you to fix this, please, on your paper. Don't look at what I've written. Listen to what I'm saying. I did not need to multiply by 3 that third time, so the answer is not 243. The answer is 81. So I was just a little bit confused when I made this key, but I figured it out now. So it's 81. Now when we write the number with exponents, that just means instead of writing 3 times 3 times 3 times 3 and taking up all that space, we're going to write it in the shorter form. So we're going to write 3 to the 4th power. And that 4th power means that we are multiplying the 3 4 different times. So since I see 4 3s, my exponent is 4. When we name the exponent, that just means that we're writing down what the exponent is. It's to the 4th power. The exponent is 4. And our base number is just the number that we're multiplying. So we're multiplying the 3. So our base is 3. Look with me at number 8. You've written in the title, which is number of blocks. And the correct answer is 43. Now, part B, you're going to see this every week. So if you're still not quite sure what it's asking you to do, I'm going to explain that to you. When it says to generate additional data, that just means write another fact from the data. What is something else that we could learn from that data? Or what is something else that they could have asked us instead of the question that they asked? Now I want you to take it to a high level. We don't want to just be, saying how many giraffes were there or something like that. We want to make sure that we're giving some data that compares at least 2 different things. But your answers will be different on that. So as long as you have something there that you learned from the data, then you are good. Let's go back to number 9. we're given 9 times 4 minus, open parentheses, 5 plus 8, close parentheses. So first we're going to solve, and a lot of you have hopefully written PEMDAS. That is your reminder. Also, we want to use that Dorito method. We want our answer, or I'm sorry, our work to be in the shape of an upside down triangle, like you see in green here. So all of this work should be on your paper. If it's not, you need to write it down now with your red pen so that you can get credit. So I'm starting by writing the equation, 9 times 4 minus, open parentheses, 5 plus 8, close parentheses. Now I know that parentheses come first, and since there's an operation that is inside parentheses, I'm going to start with that. Let's bring our 9 times 4 and our minus sign down to the next row. 5 plus 8 is 13, so that's the only thing I'm changing on this line. Remember, one step per line. I don't have any exponents, but I do have some multiplication or division. So 9 times 4 equals 36. So let's bring that down along with our minus 13. And that's all we have for multiplication and division. So our last step is to add and subtract. 36 minus 13 equals 23, and we are done. And finally, let's look at number 10. You have 0.29, 29 hundredths. And it's asking you to change that number from meters to centimeters, meters to kilometers, liters to milliliters, all kinds of things. So this is what we call metric conversions. This is the metric system. And if you've been a little bit confused about the metric system and how to answer number 10 so far on your mountain math, then after today, you should be great at this because it's actually really, really easy. There is no calculating involved. All you're doing is moving decimal points and putting zeros into blank spots. That's all we're doing. So I first want to go over with you what I've written down here. So if you have not already written this, please write this down because you want to have something to look back at to help you next week. Because next week, we're going to expect you to be really good at this and be able to do it by yourself. So, the way that we remember this is King Henry died by drinking chocolate milk. And you'll see that I put a big box around B. That B stands for base. So that's our meters, our liters, and our grams. So anytime you just see meters or liters or grams, you're going to start right here at the base. Now this is kilo, like kilograms, or kiloliters. Kiloliters, sorry, not killer, kilo. The H stands for hecto. Now we have two D's, so this first D stands for deca. So you might see it two different ways. You might either see a capital D, or on your mountain math, it's shown as a DK. So if you see DK, then that means that first D, the deca. And then we have our base. And then we have deci, which is either a lowercase d or maybe just a d by itself. And then centa, centi, centimeters, centiliters, centigrams. And then we have milli. So all you have to do in order to convert during the metric system, through the metric system, is to start with your number, 0.29 in this case, and then we just look to see how many times we need to move our decimal point. So meters to centimeters, that means that's our base, and we're going to the little c. So from the B to the little c, we're going to move 2 places to the right. And I've put that in there in green so that you can see. 2 places to the right, and so I'm going to do the same exact thing on my number. 0.29, the decimal point moves 2 places to the right, and I get 29 centimeters. And you're writing this down along with all of the work if you didn't quite get it. That way next Tuesday when you see number 10, you'll be able to do this no problem. This is actually one of the easiest ones on there because you don't have to actually do any calculations. Okay, let's look at B, meters to kilometers. Well, to go from meters, or my base, to the K, I have to go 3 places to the left. So we're starting with 0.29, 29 hundredths, and going 3 places to the left. And we're filling in all of the empty places with zeros. Liters to milliliters. Meters is our base, remember. So we go 3 places to the right. And so on our number, we go 3 places to the right. Liters to decaliters, that's DK or a capital D. We move 1 place to the left, so we're only moving 1 place to the left in our number. Grams, which is our base, to milligrams, we're going to move 3 places to the right and move 3 places to the right in our answer. Grams to hectograms moves 2 places to the left on our chart and on our number, 2 places to the left. Milliliters to liters, that's little m to our base. Liters are one of our bases, so we move to the left 3 times and do the same thing on your number. So notice on each one of these, we're starting with 0.29 and we're moving the decimal point either to the left or to the right. Milliliters to centiliters only moves 1 time to the left. Kilograms to milligrams moves 6 times to the right. So we're starting with that K and we're going all the way to the little m. 6 times to the right. And then kilograms to decigrams, the little d, is 4 times to the right. So next week when you see this, it should be no problem at all. Remember, mountain math is one of those things, it goes in your journal for a reason. It's so that you can look back at it, see how you solved it last week or the week before. And so it should be getting easier and easier each week for you. All right, if you will go ahead, please, and put your mountain math in the front pocket of your folder. You can put away your red pen, get your pencil back out, get ready to start class. Excuse me. And then in your journal, please turn to the next clean page, and we're going to take some notes today. Get this all situated. Okay, so with me, put your title. This is Sales, Coupons, and Rebates. And our date is 9/29, September 29th. And then if you'll flip to page 1 where your table of contents is, and whatever page this is on, you're going to put sales, coupons, and rebates on your table of contents so that it matches the page in your journal. Okay, so sales, coupons, and rebates. These are all ways of saving money. And they all kind of work the same way. So we might do an example where something is on sale for 10% off. And then you might see a problem later on where it says that it's a coupon for 10% off. And that's fine. So these are all basically the same thing. They all work the same way. And there are two, let's write this in a different color. methods that we can use to save money with sales, coupons, and rebates. So the first way is with dollars off. Okay, so this is our first way of saving money with sales, coupons, and rebates, and that's dollars off. So if you'll go ahead and put a little squiggly line here, and we're going to do an example. Okay, please write this with me. Teddy buys a new guitar that normally sells for $229. Okay, so normally it's $229, but it is on sale for $25 off. What is the sale price? Okay, and when it asks for the sale price, they mean what are you going to pay after the discount or after the coupon or the rebate? What's the sale price? So I want to look at my information here, and I know that it normally sells for $229, but it's on sale for $25 off. So this is a dollars off type of problem. And this is the easiest. All we have to do in a dollars off problem is subtract the normal price minus the discount. That's all we're doing. Normal price minus the discount. So let's see what that might look like in this situation. Well, our normal price equals $229. And then our discount equals $25. So we need to make sure that we're lining up our decimal points just like we would anytime we're adding or subtracting. Make sure you have that minus sign there. And let's drop our decimal down to our answer. 9 minus 5, 2 minus 2 is 0, and 2 comes down. So that means that my sale price is $204. So the sale price is $204. So that's the first way. Now, it might have said, instead of it was on sale for $25 off, they might have said Teddy had a coupon for $25 off. Or maybe there was a mail-in rebate for $25 off. It's all the same thing. Okay? So you're not worried about the word sale or coupon or rebate. You're worried about the original price and you're worried about the discount. That's all that you care about. Because remember, these three things really are the same. We treat them the same way. Okay, and then our second method, this one's a little bit more complex. This is a percent off. And you already know from calculating sales tax that percents kind of require a few more steps. It's not that bad. It's just a little bit more. So we're going to extend our little separator here. And we're going to keep using Teddy and his guitar. So let's rewrite our problem. Teddy buys a new guitar that normally sells for $229. Okay? Our same guitar, but this time it is on sale for 25% off. What is the sales price? So whenever we're doing percent off, we're not just going to subtract like we would with dollars off, because up here it was dollars minus dollars, easy peasy. But down here, first we have to change the percent to a decimal. And you're a pro at that already. So let's leave a little bit of space there for that. And then we have to multiply the decimal by the price. And then in this case, we're going to come all the way down here. Then we have to subtract. So this is the only situation where you're really going to subtract after you have multiplied by the decimal. So subtract the price minus the discount. So let's do this example. We still have $229, but this time it's 25% off instead of $25 off. So they're definitely not the same thing. Let's look here. 25%. Okay, so this is one of those cases where you have a disappearing decimal. 25%. The decimal really is right here, but it disappeared, so we're going to put it back. And then we're going to move 2 times to the left, which is the same thing as dividing by 100. So 25% equals 0.25, 25 hundredths. We've changed it to a decimal. Now we can actually use it. We really can't use a percent that often. Usually we have to change a percent to a decimal so that we can work with it. So now it's time to multiply the decimal, right here, by the price, $229. And I don't really need that 0.00 since it's an even dollar amount. I'm going to multiply by 0.25. So 5 times 9 is 45. I'm going to carry my 4. 5 times 2 is 10, plus 4 is 14. 5 times 2 is 10, plus 1 is 11. So I need to put a placeholder or a 0 or something there, whatever you want to put there, to make sure that you don't put a real number there. And we're going to get rid of that 4 and that 1 that we carried. We don't want to accidentally use them again. Alright, so now let's multiply the 2. 2 times 9 is 18. carry a 1. 2 times 2 is 4, plus 1 is 5. And 2 times 2 is, 2 times 2 is 4, plus 1 is 5. And then 2 times 2 is 4. And we need to add my addition sign there. 5 plus nothing is 5. 4 plus 8 is 12. Carry your 1. This is 7. And this is 5. Now let's look back here. I have 2 digits after the decimal, behind the decimal in my factors, in my problem. So I have 2 digits after the decimal in my product. Okay, so now we've actually found the amount that he's saving. So let's say that the question asked you, what is the amount of the discount? Okay, if the question were going to ask you just that, then we could stop here. And we would say he gets $57.25 off. Okay, so this is our discount. But, of course, we're not done because it said, what is the sale price? And when it says, what is the sale price, that means we actually have to figure out, after the discount, how much is Teddy going to be paying. So, we're going to subtract the price, which is $229, minus the discount, $57.25. Let's come right over here and work this out. $229, I'm going to put my decimal in 00 because I need to line these up, minus $57.25. So let's drop our decimal and then we can start subtracting. Okay, I'm going to have to borrow here. So this 9 becomes an 8. And this becomes a 10, but really I'm going to have to borrow from that again. So that becomes a 9 and this becomes a 10. Make sure you've gotten all of your borrowing done. Alright, 10 minus 5 is 5. 9 minus 2 is 7. 8 minus 7 is 1. 2 minus 5, gotta borrow again. So this is a 1, and 2 becomes 12. 12 minus 5 is 7, and we can just bring down the 1. So this is our sales price. $171.75. Now before I walk away and decide that this is my final answer and I'm ready to move on, we need to check and make sure that it's reasonable. So obviously if I'm buying something for $229 but it's on sale, then my sale price should be less than $229. Okay, so if you got something more than $229, then there's probably something you messed up on that you need to go back and check. So if we look at this, in this case, was it better to have $25 off or 25% off? Well, let's look. We have $204 or $171.75. Well, I'd rather have the second one. So in this situation, 25% off was actually better for Teddy. So go ahead and keep your notes out, but also turn to your sales, coupons, and rebates assignment. So you'll see this in your work. This is your work for today. Oops, sorry. Go ahead and make sure that you have your full heading, your first and last name, your class period, and your desk number. And you'll see that you lucked out in this case. Problems 1 and 2 are actually going to be done with Professor Berger. So I'm going to play a video for you. I'm going to play this first video. And Professor Berger is going to work out this whole problem with you. And so what I need you to do is to work out exactly what he has. So anything that he puts on the screen, we expect to see on your paper so that you can look back and use these two examples to help you. You're going to have 8 problems after this to do by yourself. So keep your notes out. You want to always be referring back to those, but we're going to now watch this video.
You know, discounts and sales are always fun when we see them in the store, especially when they're on products that we want to buy. But suppose that there are different types of discounts and different types of incentives. Which one do we pick? Well, it turns out math, as always, comes to the rescue. So let's take a look at a fun little story and see how math allows us to be wise consumers. Sean got a waterproof camera for his birthday and wants to buy an accessory pack that includes a case and a floating wrist strap, which sounds like great fun. Now, he finds the accessory pack at 2 different stores, and the question is, which store has the lower price? So here are the fun facts that we know about these 2 different stores. The first one, Don's Cameras, sells the pack for $18.99, but is offering a $5 off discount, which is awesome. It means that you have to pay $5 less. So that sounds like a pretty good deal. Now, at Best Photo, the regular price is $19.99, but they're offering a special 25% off. Wow, 25% off sounds huge compared to just a mere $5. So it sounds like maybe Best Photo is the best option. Well, let's use math thinking and see if that's right or not. So with Don's camera, that's actually going to be really, really easy, isn't it? Because with Don's camera, all we have to do to figure out $5 off is just subtract. So for Don, all we have to do is take $18.99 and then subtract $5. That's what it means, after all, to say $5 off. And when we do that subtraction, we see $13.99. And that is the final sale price, if you will, with the discount. And that's $1 at Don's Cameras. Okay, great. Now, what about Best Photo? Well, Best Photo is saying 25% off. So off means it's still a discount, so we still have to subtract, but we have to be careful exactly what we have to subtract. So we start with the $19.99, and now we have to subtract 25% of the price. Well, that means 0.25, and what does of means? Of means times the original price, $19.99. Okay, so what does this work out to be? Well, you could actually work this out in kind of tremendous detail, and that's actually a dollar sign right there. So if you work this out in tremendous detail, just dropping the dollars for a moment, we see $19.99, that's the easy one. But if you actually work this out, you see minus 4.9975, which sounds to me a lot like 5, doesn't it? But anyway, if you actually subtract this, look at this difference, you see 14.9925. And so if we just round to the nearest cent, this becomes, in dollars, $14.99. And that is the price of Best's. So Don's, with the $5 off discount, is $13.99. Best Photo, with the 25% off on $19.99, turns out to be $14.99. So is Best the best price? I don't think so. This is much better. So in fact, Best is not best. In fact, Best is worse. So we should call this Worst Photo maybe, because in fact it's $1 less expensive here at Don's Camera. So just because you see a big 25% off, it doesn't mean that that's always the best buy. We really have to kind of think through the math and do the calculations and really compare before we buy. That's the beauty of mathematics. It provides us with a powerful tool that we can always use. As long as our brains are turned on and the mathematics is correct, we'll never go wrong and we'll always buy the right product. Have fun thinking about math and these discounts, and I'll see you soon.
Alrighty guys, so you should now have all of number 1 worked out. Professor Berger worked that out with you, and you have all of his work on your paper. So now if you will please scooch up and look at number 2. This is a slightly different problem, still dealing with sales, coupons, and rebates. So I'm going to show you another video, and I'd like for you to work out this problem with Professor Berger as well. And at the end of this video, then you will be able to complete the rest of the assignment by yourself.
You know, incentives and sales and promotions are really exciting, but sometimes we have to be careful to make wise decisions. And the math that you and I are thinking about together will allow us to be wise and thrifty. So let's take a look at an example where we can actually make wise decisions just thinking about math. Awesome. Here we go. Bella and 2 friends went on a trip together. Bella wants to buy custom photo books for herself and her friends as a souvenir. She'll order 3 copies of the book. The question is, which is the better buy? So let's check it out. There are 2 places she can get those books made. Treasured Moments and Precious Memories. Now at Treasured Moments, the regular price is $35, but wait a minute, there's a special crazy. Buy 2 and you get 1 free. Wow. So that sounds pretty good, doesn't it? But check out what Precious Memories is offering. They're saying our regular price is $29, but we'll give you a rebate. We'll just give you cash back $8 per book for up to 2 books. So, which is the better deal? Look, the $29 and you get money back, this sounds like the real bargain. $35, I don't know. But it doesn't matter what we just think by glancing at it, it's what we think after we do the math. So let's see what the math says, because numbers never lie. So we need 3 copies of the book, and let's see what each side gives us. So the first place, we see that with Treasured Moments, $35 per book, but if we buy 2 of them, we get the 3rd for free. So basically, we'll get 3 books for the price of 2. So all we have to do to figure out the price of 3 books with this special is just look at 2 times $35. Do you see why? Because once we buy 2 books at the regular price, we get the last one for free. And that gives us the 3. So what is 2 times 35? It is, of course, we all know, $70. Okay, so that's the first possibility. We could spend $70 for these 3 custom books. Or, let's see what the alternative is. Let's see what happens at Precious Memories. There, we pay $29 per book, but we get an $8 rebate for up to 2 books. So first we have to buy all 3 books. So here we have to actually look at 3 times $29. Well, that's not bad. $29 is not a lot of money. And then we get a rebate. So we're going to get money back. That means we're going to subtract off the amount we pay, because we're going to get money back. Subtract off $8 per book, but a limit of 2. We're buying 3 books, so we only get a rebate of 2 books. That means we're going to get an $8 rebate twice, which means 2 times $8. Right? That makes sense because we have a limit of 2, and for each of those 2, we get $8 back. Now, what does this work out to be? Well, 3 times 29 works out to be 87 minus, and 2 times 8 we all know is 16. And so what is 87 minus 16? It's $71. So that's what Precious Memories is going to charge us for the 3 books? Well, now I think it's pretty clear what's precious and what's treasured, because we see that the precious memories actually are going to charge us an extra $1, whereas we get the exact same thing at treasured moments for $70. And so what we see is that we definitely want to go and treasure our moments, because in fact, that's the place where we get to also treasure a dollar savings. So sometimes when you look at the deals, it might not be clear which deal is best, but by thinking about the numbers and setting up what the math is, writing down all the steps, doing the subtraction, multiplication, percentages, or whatever is involved, then you can get it right down to real numbers. And once you got down to real numbers, you always know which is bigger. In this case, we know that 70 is certainly less than 71. Have fun making great deals, saving lots of money, and thinking mathematically. I'll see you soon.
So now that you have numbers 1 and 2 completed as examples, that was your guided practice. Now I would like for you to do numbers 3 through 10. Now, if the sub allows you to work with a partner, then you'll be able to work with a partner on this. If not, then it's all on your own. So make sure that you are on task, that you are staying focused, and that you're completing this today. So it starts with some simple problems, but by the time we get to the back, these get a little bit more complicated. So make sure that you're paying attention to every little detail. Some of these problems have a few more steps than others. So if you happen to finish early, which I don't think you will, but if you happen to finish early, then you have some things that you can look back at. You can work ahead in mountain math if you have nothing else to work on. But you will be working on something for math throughout the rest of the period. All right, have a great afternoon and enjoy finding some discounts.